Hi, everybody. Yesterday, you took a look at an experiment where copper chloride was dissolved in water, and into that water was put a cathode and an anode. This is the cathode, it's the negative electrode, and this is the anode, this is the positive electrode. And you saw that copper chloride was dissolved in there. Copper chloride, I drew a picture of it right here. It's got one copper, that's the square, and it's got two chlorines, that's one here. They're sort of triangles. I'm trying to make them as triangles on here. All right, and that is going to be dissolved in this water. But remember, there's a positive and negative electrode also stuck in the water, just like the ends of a battery or something like that. All right, and you saw in the video something happened. You saw in the video that bubbles were formed on the positive electrode. And in the worksheet yesterday, I mentioned that these bubbles smelled like swimming pool. Well, you guys all know what swimming pools smell like, right? If you go in a swimming pool and you smell it, you say, oh, that smells like chlorine. I think most people say that anyhow. Okay, so we can kind of guess that these bubbles were actually chlorine gas that formed on this positive electrode. Okay, well, that's weird because up here we didn't put in chlorine gas, we put in copper chloride, and yet we're getting chlorine gas over here. And over on this side, the man showed you that there was a reddish material put on the sides of this. It looked kind of like the material that a penny is formed from. And that material, I'm just going to kind of draw it on there if I can. That material, there it is. It was just kind of a covering on there. And that material was copper. Okay, it was like the covering on a penny. It was the color of a penny. So what must be going on inside um, inside this container? Well, it's clear that this copper chloride did something when it went in there, and it's clear that it broke apart into pieces. We ended up with chlorine pieces in there, and we ended up with copper pieces. And that's if I added one of these, but let me throw in another one. There's a square and a couple more chlorines, all right? It becomes clear that they must have come detached. They must have broken apart in that liquid when it dissolved. Remember earlier in the year, we said, well, when things dissolve, they become very, very small particles. You can't see them anymore when they're dissolved, right? And so in this case, it looks like the copper chloride came apart because the chlorine ended up over here and the copper came over here. And the only way that could have happened is if they broke apart. Now, why would the copper come over here to the negative side? Well, it must be that the copper ended up with a positive charge. And it must be that the chlorines ended up with a negative charge because they went to the positive electrode. All right, so they had a negative charge and they went that direction. So I'm drawing an arrow on there to show you which way it's going. Okay, so that's fine. It had a negative charge, and this chlorine must have had a negative charge too. But if you're paying close attention, you know that there must be something wrong with my copper because this started out as being neutral. Everything normally is neutral. And I ended up with two chlorines, each which had a negative charge. So copper must have had a positive 2 charge. It must have two positives on it to equal out the negatives because overall this was neutral. So there must be another positive here, which I'm going to try to draw on there, another positive right there on that. And then the copper went this way. All right. So we ended up showing something really interesting that copper chloride breaks up into copper, which had a +2 charge, and chlorine, which each had a -1 charge. You've got to keep this in mind what's happening here, that copper must have had a plus charge, +2, and chlorine must have had each a -1. At least that's our